This is the Vehicle Assembly Building. NASA has used it to construct massive rockets before they lift off from the launch pad. In this video, we'll see inside the building and how it's been used for more than half a century. This video is sponsored by Brilliant. In the 1960s, NASA was headed to the moon. The launch vehicle for this was the giant Saturn V rocket, with the Apollo spacecraft at the top. They needed a place to assemble the pieces of the rocket, and the launch pad wasn't set up for this. This is why they built the Vehicle Assembly Building, often just called the VAB. This building is still in use today. It's a controlled environment that protects from the outside weather. It keeps the rocket safe until it is moved to one of the launch pads, usually just a few weeks before the launch. The VAB has been mainly used to assemble 3 rockets: the Saturn V, which was used by the Apollo program, the Space Shuttle for the Space Shuttle program, and the Space Launch System, or SLS, which is currently being used for the Artemis program, which will return astronauts to the surface of the moon. Construction of the VAB started in 1963, and it took 3 years to build. The building cost $117 million US. That's more than $1 billion US in today's money. Over the years, they expanded the facility around the building and also added the NASA logo, sometimes called the meatball logo, and a giant American flag on the side. The VAB is 160 meters tall. For a good size comparison, here's the Statue of Liberty and the Eiffel Tower. There are some open areas inside the building that go all the way to the roof. Because of this, some people consider it to be the world's largest one-story building. But after looking inside, that definition might be a bit of a stretch. There's a lot of different platforms in here. The VAB is located in Florida at Kennedy Space Center. The VAB is here, and on the other side is Launch Complex 39A and 39B, more than 5 kilometers away from the VAB. The large distance is mainly for safety. This path is called the Crawler Way. It's a 40-meter wide double pathway road. When the rockets are ready, they are transported from the VAB all the way to one of these 2 launch pads. They use some massive machinery to get this done. We'll talk more about this later in the video. These enormous rockets are built in quite a few different pieces. These rocket pieces have been built in several locations across the United States. Then they are shipped to Kennedy Space Center in Florida. Some of the pieces arrive by barge on the water at this turning basin. And other pieces can be flown by airplane and land on this runway, which was built for the shuttle program. Another way they can arrive is by train. Then the pieces of the rocket are brought over to the VAB. This smaller building next to the VAB is the Launch Control Center, which is facing both of the launch pads. Let's take a look inside of this gigantic building. This area is for the low bays. They can work on parts that aren't quite as big. The low bays were mainly used during the Apollo program in the 60s and 70s. And the tall section of the building is for the high bays. There are 4 high bays, numbered 1, 2, 3, and 4. These are the large open spaces that are big enough to fit a rocket. The foundation for the VAB extends beyond the north side of the building. There is space to build 2 more additional high bays, and if needed, they can even extend the roof to allow for larger rockets. However, as of the year 2024, there are no current plans to do this. On the sides of each high bay, they call these towers. So this is Tower A, Tower B, and then C, D, E, and F. They go all the way to the roof. Right down the center is the transfer aisle, which runs the entire length of the building. On each side are retractable doors, large enough to fit the massive parts of the spacecraft and rockets. Despite the size of the doors, they are not the largest openings to the building. Each high bay has 4 door panels that move left and right, and then 7 door panels that move up and down. It takes about 45 minutes to completely open the doors. The main part of the building has no air conditioning, but once these doors are opened, it does provide a draft which cools things off. There are bridges and catwalks so that workers can get in between the different parts of the building, and plenty of elevator shafts to allow workers to get to the different levels. Inside the building, there are several yellow cranes used to lift the massive pieces of the rocket. There is one crane that goes along the transfer aisle. It can carry up to 159 metric tons. And then we have 4 more cranes that service the high bays. Originally, there were only 2 high bay cranes, but now there are 4 of them. These 2 cranes service high bays 1 and 2, and these 2 cranes service high bays 3 and 4. The strongest cranes can lift as much as 295 metric tons. The operator for the crane goes inside of the cab here. I hope they're not afraid of heights. We'll see these cranes in action a little bit later. For the rest of the video, I'd like to show how the building was used for each space program. First, we'll start with the Saturn V, back when the VAB was a brand new building. The high bays used most often were High Bay 1 and High Bay 3. This is because they are facing towards the launch pad. It makes things a little bit easier. Inside of each high bay, they had several pedestals. Resting on top of this is the mobile launcher and the launch umbilical tower. The stages of the Saturn V rocket are brought into the transfer aisle. This is the first stage of the Saturn V. Initially, 2 of the cranes are used to lift it. The transfer aisle crane attaches to the lower end, and the high bay crane will attach to the upper end. Both cranes work together to lift and rotate the rocket stage. Now just the high bay crane is used to lift it the rest of the way. This all happens very slowly. The first stage weighs about 132 metric tons. The crane operator can't afford to make any mistakes here. They bring it over into the high bay and gently set it down on the mobile launch platform. On the sides of the high bay are retractable multi-story work platforms. There are 5 pairs of these. They are literally as big as a house. They are specifically designed to fit around the Saturn V. Once a piece of the rocket is in place, the platforms can move into position. This allows workers to access different parts of the rocket. Next, the crane lifts up the second stage of the Saturn V. More platforms can now be moved in place. Now the third stage. Right above the third stage is where they put the instrument unit. This is like the brains of the rocket, controlling it all the way through the launch. The very top part includes the command and service module and the lunar module, which is the part that actually lands on the moon. This whole section is lifted up as well and gently placed at the very top of the rocket. During the peak of the Apollo program, 3 of the high bays were used at the same time to assemble the Saturn V rockets. Once a rocket is ready to go, the work platforms are retracted, and the high bay doors are opened. This is called the crawler transporter. This is what moves the rockets all the way to the launch pad. NASA built 2 of these enormous machines. It slowly moves underneath the mobile launch platform and then lifts it up. Now the rocket can begin its journey to the launch pad. This is called the rollout. The crawler transporter only goes a little over 1 kilometer per hour. This means it will take several hours to get to the launch pad. All that work, and we're finally ready to launch a mission to the moon. After the Apollo program, NASA started making plans to support a reusable spaceplane, the Space Shuttle. There were 135 shuttle missions over a period of about 30 years. The shuttle had missions in low Earth orbit. It was also used to construct the International Space Station. The To save money, they tried to reuse what they could in the VAB, but there were some specific changes that were needed to accommodate the shuttle. There's quite a bit of height difference between the Saturn V and the Space Shuttle. This means the platforms in the high bays couldn't be used anymore. Some of these platforms were modified and then relocated specifically for the shuttle program. There were 4 pairs of these platforms. High bays 1 and 3 were mainly used to assemble the space shuttle. High bays 2 and 4 were used to process and store the external tank for the shuttle. They were stored in the checkout cells on the sides of the high bays. High bay 2 was also used as a safe haven in case of hurricanes. And High bay 4 was also used to sometimes store an orbiter while it waited for the next mission. The north entrance to the transfer aisle needed to be widened by 12 meters to allow the orbiter to enter. A slot right here allowed for the passage of the vertical stabilizer. The launch umbilical towers were permanently moved over to the launch pads. During the shuttle program, they called it the Fixed Service Structure. The Saturn V mobile launcher was repurposed for the space shuttle and renamed the Mobile Launch Platform. The first part of the shuttle to be assembled is the Solid Rocket Boosters, or SRBs. They are built in several different pieces with their solid fuel already inside of them. One by one, they are lifted up by the crane, moved over to the high bay, and assembled on top of the mobile launch platform. The work platforms are moved into position around the SRBs. Next comes the external tank. This was carefully placed in between the SRBs. When it's time, they'll get ready to attach the final piece, which is the orbiter. 2 of the cranes are used to lift it up vertically, and then the high bay crane rotates it diagonally and lifts it into position. The orbiter has to be rotated so that it can fit in between the opening for the high bay. Then it's attached to the rest of the rocket stack. Once it's ready, the shuttle needs to get to the launch pad. This is very similar to what we did with the Apollo program. The crawler transporter carries the mobile launch platform and the space shuttle all the way to the launch pad. After the space shuttle was retired in 2011, it was time to prepare for the Space Launch System, or SLS. This will be used to launch the Artemis missions, which will return astronauts to the surface of the moon. The VAB underwent a massive renovation process that included replacing much of the wires and cables that were installed in the 1960s. The space shuttle platforms in High Bay 3 were removed and new work platforms were installed for SLS. There are 10 pairs of these platforms. These are smaller, customizable platforms that can even move up and down as needed. The crawler transporter was upgraded, and new mobile launchers were built. The SLS rocket is much heavier than previous rockets. SLS is launched from pad 39B. 39A is now used by SpaceX. Stacking the rocket is very similar to what we've already done. NASA is getting quite good at this. SRBs are stacked first. These are very similar to the SRBs on the space shuttle, but with a few changes and upgrades. Then comes the core stage. Very carefully lowered between the SRBs. And finally, the upper stages. Inside of here is the brand new Orion spacecraft. Once we're ready, it's time for the rollout. The first SLS mission was Artemis 1, launched in November of 2022. This was an uncrewed launch, which meant it didn't have any astronauts on board. It was a test flight around the moon. The next mission, Artemis 2, will launch 4 astronauts around the moon as early as 2025. This will be the first time that astronauts have left low Earth orbit since the 1970s. The vehicle assembly building isn't just a place where rockets are built. It's a testament to what humans can achieve. We can solve problems and do things that were once thought to be impossible. In the future, we'll need more people like this, those that have strong backgrounds in science and engineering. The best way to learn this is with Brilliant.org. Brilliant is where you learn by doing, not just reading a textbook, but actually trying it out. This is a very effective way to learn. You can develop a deep understanding so that you're better prepared to meet the challenges of the future. By doing Brilliant for just a few minutes each day, you'll develop strong problem-solving skills and a powerful habit of learning. Brilliant has thousands of interactive lessons and topics that are relevant to the world around you, like math, programming, and AI. For me, Brilliant makes things come alive and is a reminder that learning should be fun. You can try it out for free for a full 30 days. Everything Brilliant has to offer. Just go to brilliant.org/JaredOwen. You can also get 20% off the premium subscription.